Good morning to all. In this session, I will be taking up part 4 of chapter States of Matter of 11th standard. I shall discuss a few properties of liquids, that is vapor pressure, surface tension and viscosity, which depend upon the intermolecular forces of attraction. After watching this video, you will be able to define vapor pressure, normal boiling point and standard boiling point. Second, definition of surface tension and surface energy and their units. Third, understanding cause and applications of surface tension. Fourth, knowledge of terms viscosity, laminar flow, and coefficient of viscosity. Fifth, dependence of surface tension and viscosity on temperature. Let's first take up the term vapor pressure. Suppose we take a liquid in a closed vessel, then you know that evaporation of liquids takes place at all temperatures. So more energetic molecules from the surface of liquid, they will go into the space above the liquid in the form of vapors. So initially the rate of evaporation will be high, but as more and more vapors collect in the space above the liquid, they start colliding with each other and with the walls of the container and lose energy. So condensation begins. So slowly rate of condensation also increases. Now when the rate of evaporation becomes equal to rate of condensation, a stage is reached which is known as equilibrium stage. So at equilibrium stage, the number of water molecules which is going into the vapor phase is equal to the number of molecules which are going back from vapor phase to liquid. So at this stage, the pressure exerted by the vapors on the surface of the liquid becomes constant. So this pressure is known as vapor pressure. So we can define vapor pressure as the pressure which is exerted by the vapors on the surface of liquid in equilibrium stage. So vapor pressure depends upon two factors. One is nature of liquid and second is temperature. So greater are the attractive forces among the molecules of a liquid. So less will be their tendency to go into the vapor phase. So vapor pressure will be less. And if we increase the temperature, so more energy of the molecules will increase. So more and more molecules will go into the vapor phase and vapor pressure will increase. Now, suppose we have taken a liquid in an open vessel and we are heating it, then as the temperature is rising, evaporation is becoming more and more vapors from the liquid are going into the vapor phase. So vapor pressure will increase. Now at a particular temperature, what will happen that the vapor pressure of the liquid will become equal to the external pressure. Now, when vapor pressure of the liquid becomes equal to the external pressure, then vaporization not take only takes place from the surface, but vapors, vaporization also starts from the bulk of the liquid. So then we say that the liquid is boiling. So the temperature at which the liquid starts boiling is known as boiling point or boiling temperature at that pressure. And at this temperature, the vapor pressure of a liquid is equal to the external pressure. At 1 atmospheric pressure, boiling temperature is called normal boiling point. And if pressure is 1 bar, then the boiling point is called standard boiling point. Standard boiling point is slightly less than normal boiling point as 1 bar is slightly less than 1 atmosphere. Now, normal boiling point of water is 100 degrees Celsius at 1 atmosphere, but its standard boiling point is 99.6 degree Celsius. The temperature when the density of a liquid and vapors become the same, that is the boundary between liquid and vapors disappears, is called critical temperature. Now, at the hilly areas, when we go to higher altitudes, atmospheric pressure becomes low. Now, as the atmospheric pressure is low, the boiling point of the liquid is also lower down. It also decreases. So that's why we need pressure cooker at hilly areas to cook vegetables. Similarly, in hospitals, surgical instruments are sterilized in autoclaves by increasing the boiling point of water by increasing pressure with the help of weight. The next property of liquids is surface tension. Now, before we define surface tension and surface energy, let's look into the cause of the surface tension. Why do the why do the surfaces of liquids behave as stretched membranes? So when a molecule is in the bulk of the liquid, it experiences equal intermolecular forces from all sides. So the molecule does not experience a net force, but the molecules on the surface experience a net downward force, and thus they have more energy than the molecules in the bulk or interior. So liquids tend to have minimum number of molecules at the surface. So liquids tend to have minimum surface area. So because the molecules on the surface are energetic. So if the surface of the liquid is increased by pulling a molecule from the bulk, then attractive forces will have to overcome. They will have to be overcome. This will require energy. So greater are the attractive forces among the molecules of a liquid, greater energy will be required. So the energy required to increase the surface area of the liquid by 1 unit is defined as surface energy. Its SI unit is joule per meter square. Now we can define surface tension as the force acting per unit length perpendicular to the line drawn on the surface of the liquid. It has the dimensions as kg per second square, and in the SI units it can be expressed as Newton per meter. The lowest energy state of the liquid will be when surface area is minimum. So spherical shape satisfies this condition. That's why mercury drops are spherical in shape, because sphere has minimum surface area, and when surface area is minimum, then the liquid is in the lowest energy state. This is the reason that sharp glass edges are heated for making the glass smooth. On heating, the glass melts and its surface melts, and the surface of the liquid tends to take the rounded shape at the edges, which makes the glass edges smooth. Similarly, we can explain rise or fall of liquid in a capillary with the help of surface tension. Next property of liquids which depend upon intermolecular forces is viscosity. Viscosity is the measure of resistance to flow which arises due to internal friction between layers of fluid as they slip past one another while liquid flows. When a liquid flows over a fixed surface, the layer of molecules in the immediate contact of surface is stationary. The velocity of upper layers increases as the distance of layers from the fixed layer increases. The type of flow in which there is a regular gradation of velocity in passing from one layer to another is called laminar flow. If the velocity of the layer at a distance dz is changed by a value du, then velocity gradient is given by du by dz. So dz is the distance between two adjacent layers, and du is the velocity difference as it is visible from this diagram. So the middle layer has velocity u, and the layer which will be above it will have velocity u plus du. Similarly, the layer which will be below the middle layer, it will have velocity u minus du. So there is difference of velocity du between two layers which are at a distance dz, and A is the area of the layer. Now a force is required to maintain the flow of layers. This force is proportional to the area of contact of layers and the velocity gradient, that is du upon dz. So F is directly proportional to area of contact of the layers. It is directly proportional to velocity gradient du upon dz. So on combining the two, we get F proportional to A into du upon dz. And on removing the proportionality sign, we get a constant eta, which is known as coefficient of viscosity. So we can define coefficient of viscosity as the force required to maintain the flow of layers when the area of contact is unity, and the velocity gradient is also unity. So this coefficient of viscosity has units Newton second per meter square. Now both viscosity and surface tension, they are dependent upon temperature. So when we increase the temperature, what happens? Kinetic energy of the molecules increases. They go away from each other. The intermolecular forces of attraction, they become weak. So surface tension as well as viscosity, they decrease on increasing the temperature. So then there is assignment. So first question is define surface tension and write its unit. Second, why are mercury drops spherical in shape? Third, define the terms laminar flow, coefficient of viscosity. Fourth, why window panes of old buildings are thicker at the bottom than the top. Fifth, what is the effect of increase of temperature on surface tension and viscosity? Thank you.